This is a pre-built version of the application. So first we will do a quick high-level overview of the code. So this class creates and populates the dataset tables, and this class creates and populates hard-coded two-dimensional arrays datasets. So this one has to do with hard-coded data, and this one with data coming from the database. And we can also have data coming from files, from .csv files. So this is an example. Have various positive or negative reviews. And this class prompts the user for the .csv file, table, or hard-coded data source name, and it obtains and returns data as a two-dimensional array from .csv file, or from table, or from hard-coded data source. So the directory name where we have .csv files is data, and we are from the database we are getting the data from an SQLite database, and the name of that database is data.db. And this class displays training data, conditional probabilities calculations, and classification results. So it has to do with everything display functionality. And this class contains sentiment classification calculations functionality, and this one drives the application. So it prompts the user for data source type, either hard-coded or coming from the database or from .csv file, and it picks up vocabulary words from the training data, and given a text it handles sentiment classification functionality. Next, let's do a quick demo, but first let's delete the existing database and show how we create it using create this one, create db01, and we are creating three tables: a restaurant review table, a movie review table, and a hotel review table. And we can add additional methods or remove methods that exist here. Okay, so let's refresh. So starting the application, we have those three options: either hard-coded data, or data coming from the database, or from file, and we'll use this one for hard-coded data. And this one for data coming from the database. And this one for data coming from .csv file. And let's run the application again. And let's go with the database. And we'll do the restaurant review. And we have 15 unique words. And 9 words here in the reviews that are positive, and 11 words in the reviews that are negative. So we have 2 reviews that are positive and 3 that are negative. So 15 plus 9, we end up with 24, and 15 plus 11, we end up with 26. Now in a sentiment classification application, we want to auto-classify documents. For example, we want to determine whether a review for a restaurant, a hotel, or a movie is positive or negative. Now, automatically extracting sentiment is very important for marketing, market prediction, etc. And another important commercial application is email spam detection. And to do this sentiment classification, we will be using a multinomial naive Bayes classifier, where a text document is represented as a bag of words, meaning an unordered set of words with position ignored and only using word frequency within the document, and where it is assumed that the conditional probabilities are independent and thus can be naively multiplied. So this is the bag of words vocabulary set that we built here. So here, to overcome multiplying by 0, we use add 1 Laplace smoothing. So we add 1 to the numerator here everywhere. And we add 15 to the denominator, so the number of words in the set. Next, let's go ahead and auto-classify a new review document, and the text is classified as expressing a negative sentiment. And we are using logs here, since to overcome numerical underflow, which means multiplying many small numbers together, we do language model probabilities in log format. Also, to add in log space is equivalent to multiply in linear space. So we have 2 reviews that are positive and 3 that are negative. This is where we have the 2/5 and 3/5. And we are taking the log of those in order to obtain the log prior of positive and negative sentiments. And we add that to the log likelihood of positive sentiment and negative sentiment. So for taste, we have for positive sentiment we have 2/24, and for negative sentiment we have 2/26, and for the word worst we have 1/24 and 2/26. So we add all those 3 logs together and obtain this number here, and those 3 together and obtain this number. And this one is bigger than this one, so we could have stopped here and concluded that the text classified as expressing a negative sentiment. But we went ahead and went back to prior plus likelihood of positive sentiment and negative sentiment. So we obtained those 2 numbers. And this is bigger, so we got the text as expressing a negative sentiment. And those 2 add up to 1. Finally, let's import the downloaded zip file. And do a quick test run. Maybe use this one. And maybe specify this. So text is classified as expressing a negative sentiment. And maybe try this one. Now a members only version is available for viewing by channel members at the software engineer level and above, and it includes step-by-step coding, and the source code is available for download.